Hello and welcome to the first day of notes for Calculus 3. It's not going to take very long. Um, and again, if you have any questions, you can always come to the Zoom meetings in the morning and ask me if there's anything that I need to go over, just so that you have a good understanding of everything. Now, the first thing that we're going to talk about is the three-dimensional coordinate system, which you've had this before in your math analysis trig classes. And so I'm just going to go over this. So it should be just a review for everybody. But what we're going to talk about is the three-dimensional coordinate system. So I'm going to briefly go over these page by page. I'm going to put them up on YouTube so you can look through all these. But just to go ahead and discuss this, in order to represent points in space, so this is what we want to do. We want to take everything that we've learned from Calculus 1 and Calculus 2, and instead of doing things on a two-dimensional surface, now we're going to do things in a three-dimensional surface, and so now we have the space that we can move around. So in order to represent points in space, we first choose a fixed point, O, which we're going to call the origin, and three directed lines through O that are perpendicular to each other, called the coordinate axes. And we're going to label these the x-axis, y-axis, and z-axis. The direction of the z-axis is determined by the right-hand rule. And pretty much what the right-hand rule is if you stick your right hand out and then stick your fingers straight, that's going to be the x-axis. Your thumb, which is going to be perpendicular to your fingers, is going to be the z-axis. And wherever you curl your fingers, that's going to be the y-axis. And so you move from positive x-axis to positive y-axis. And that's how we can, determine how our three-dimensional coordinate system is going to look like. So the three coordinates the three axes that we have are going to create the three coordinate planes, the xy, the xz, and the yz planes. And it's going to divide our space into 8 parts, and they're going to be called octants. Now, the first octant is driven by the positive axes, which you can see a picture of on the right. Now, to locate any point on our three-dimensional coordinate system, we're going to label these like any normal point. In the xy coordinate system, you had the x come first and then the y. In the three-dimensional coordinate system, you're going to have the x, y, and z, and they're all going to come one after each other. So A would be the x-axis, B would be the y-axis, and C would be the z-axis. And so in order to graph this, what we're going to do is we're going to just move along each axis to go ahead and find where we need to be. So in our little example here it looks like a cube, but what we're doing is in order to move A spaces from the x-axis, on the x-axis, we start at the origin, and then we're going to move out until we get to A. And then the next one we're going to do is find B, which is determined by the y-axis. So we move out how many spaces B is, and we'll get to B. After we found A and B, we need to determine C. And so we just go up on the z-axis, how far Z is, and then we'll get to our point. So just to show that, we find A. Then from A, we're going to go out our distance of wherever B was. And so we're going to move out to B, and then we're going to end up how far we need to go on the z-axis. And then here's our point. Now, we're going to do an example. And again, you can skip through this example if you feel comfortable, or if you're able to just look at the notes and determine how we got there. Now, in order to make our coordinate system, all right, I'm going to just go ahead and draw like I do an XY coordinate system. But then what I'm going to do is I'm going to go ahead and draw a line diagonally through that coordinate system. And now that's going to be the x-axis. The x-axis is the axis that's going to come towards us. The y-axis is the one that will go from left to right. And the z-axis is the one that's pointing upwards. And so there's our z-axis. Now, what we'll do is I can go ahead and label a few tacks on our coordinate system. And again, this is not going to be perfect. And I'll be very generous as you do these. And so I'm just going to go ahead and put 4 tacks. And the reason why I'm putting, 4 tacks for all these is because our highest value is going to be a 4. And so what I'm going to do is I'm going to first go along my x, y, and z. And so I'm going to go on the x-axis. I'm going to go down 2. So I'm going to move 2 on the x-axis. And then I'm going to move to the right 1. So then there is my point. And then finally, I'm going to go down to -4. So I'm going to go down on my z-axis, and I'm going to go down to -4. And now there's my point. And we'll call this point A. Now, you can just use the same coordinate system, the 3-dimensional coordinate system that I use here to plot the other one. To plot B, you can go ahead and use the same one. So if you wanted to plot, just change the color, and then you could plot back on this coordinate system. But I'm going to go ahead and just make another one just to reiterate how we're doing this. So again, I'm going to go my Z, my Y, and my X. And I'm going to go ahead and label these. And then here, the highest amount of tacks that I need to do is going to be 5. And again, you can go ahead and skip towards the end or just look at the notes that I'm going to be providing on Blackboard to determine this. And again, you don't even have to go 5 for all of these. You could go 2 on the X, 3 on the Y, and 5 on the Z. So again, once again, what I'm going to do is I'm going to plot. And so the first thing is I'm going to go down to 2. And then so there's going down to 2. Then I'm going to go on the y-axis. I'm going to go down 3. So now I need to meet those. So there's the point. And then Z, I need to go up 5. And so going up 5, there's Z. And so I'm just going to call this point B because that is the second part.